So for example 2, it's the same thing. We want to find the surface area of a sphere, a hemisphere, a hemisphere. The only difference is it doesn't tell me what my radius is. So this is going to be a two-part problem. The second part will be like what we did up in example 1. The first part will be using this information here. It tells me that the circumference of the great circle is 5 pi meters. So I have to use this information to find what r is in order to plug it back in here. So if we go back to the front, this is where we're going to use that circumference of a great circle and area of a great circle. So 2 pi r is my circumference of the great circle. So I'm going to set 2 pi r equal to 5 pi. Circumference of a great circle, which is 2 pi r, is equal to 5 pi. So this one is circumference of a great circle. I'm going to write 2 pi r. This one down here is circumference of a great circle, so I'm going to set 2 pi r equal to 36 pi. And then for these two that are both area, if you flip back to the front, area is pi r squared. So we'll write pi r squared equals 130 or 4 pi. So that's just your first step before you can solve for r. So to solve for r, to get r alone, I got to get rid of this 2 pi. So what I'm going to do is I'm going to divide both sides by 2 pi. And fortunately, since this has a pi too, it cancels on both sides. So that 2 cancels, that pi cancels. So I have r alone. R is equal to 5 divided by 2, which if you don't know is 2.5. So now when I plug that formula back in, I'm going to just use 2.5 as my r. Just to show you, if you didn't realize that this is going to cancel, if I put in my calculator 5 pi divided by 2 pi, it would also give me 2.5. So if you didn't recognize that the pi's cancel, you can plug it in your calculator. Just make sure you use parentheses. So now my second step is I'm looking for the surface area of a sphere. So if I look back at the top, my surface area of a sphere is 4 pi r squared. So I'm going to use my new r. Surface area equals 4 pi 2.5 squared. 4 pi 2.5 squared. And I get 78.5. And my units is here, it's meters squared. So if you want to try the next, after we do D, if you want to try these on your own, this circumference of a great circle would be used like this one, and then the area would be used like E. All right, so now I have area of a great circle, which if I flip on the front is pi r squared. So I'm going to set pi r squared equal to 130. So if I want to get r alone, so the first thing I'm going to do is divide both sides by pi. So I have r squared equals 130 divided by pi is 41 point, we'll round that to 0.4. So I don't have r yet. I have to find r by itself. So I'm going to take the square root of both sides. So I'm going to take the square root of 41.4. 6.4, that is my r. So the area of a great circle has a few more steps than circumference. All right, so we're finding the surface area. This one again is sphere. If it said hemisphere, I would plug this into the hemisphere formula, but it says sphere. So my surface area is 4 pi 6.4 squared. 4 pi 6.4 squared is 514.7. And it's inches squared. All right, let's try the next two. So we're doing another area of a great circle. So that formula is pi r squared, and it equals 4 pi. So I'm going to do the same two steps. Divide by pi, take the square root. This time though, when I divide both sides by pi, it cancels on both sides. So I have r squared is equal to 4. If I take the square root of 4, you should know the answer, but if you don't, your r is going to be 2. But remember, this time I'm looking at hemisphere. I want to find out what the hemisphere is. So when I do my surface area, I have to use my hemisphere formula, which is 1/2 4 pi 2 squared plus pi 2 squared. Plug the whole thing in. 1/2 4 pi 2 squared plus pi 2 squared. And you get 37.7. And it's feet squared. All right, last one. This is back to circumference. So I have 2 pi r is equal to 36 pi. When I divide both sides by 2 pi, I get r equals 18. And again, I'm doing hemisphere. So it's 1/2 4 pi 18 squared plus pi 18 squared. Oops, sorry. 1/2 4 pi 18 squared plus pi 18 squared. This is a big one, 3053.6. My units is centimeters squared. You're all set.